Hello, thank you for being here, especially this is one of the last sessions, and I'm very happy to see so many people here. My voice is slightly strained because I've done a lot of networking on the first day, so I'm still recovering, and I'll try my best to make myself heard everywhere. So, as mentioned, my name is Gamanji, and I'm a cloud platform engineer for Condé Nast. Around 1.5 years ago, I joined Condé Nast to contribute to a project that aims to create a centralized, globally distributed platform that has Kubernetes at its centerpiece. Today, I'd like to talk to you about specifically of how creating a micro open source community of Helm, or actually how we promoted inner sourcing within our company. So I would like to start by giving an introduction of Condé Nast, and I would like to start a giving of introduction of our platform as well. This is going to be followed by how our developers interact with our platform, and then it will transition of our support topology of how we exactly collaborate with our application teams. Lastly, I'm going to finish with Helm micro open source community, or pretty much what was the result of our collaboration. So without any further ado, I would like to start by saying what Condé Nast does and delivers as a product. Condé Nast has set the benchmark for print and digital publishing for more than 110 years. We operate brands that are fashion and luxury oriented, and you might be familiar with some of the brands like Vogue, GQ, Wired, Vanity Fair, AD, and many more. These are just a few of the brands that we have in our portfolio. Currently, we have 38 brands, and we distribute them in 26 languages, so it's quite a wide and inclusive range of brands we have out there. With headquarters in London and New York, we operate on an international scale in more than 12 countries. We have 86 websites overall, and they generate more than 330 million unique users every single month. So far, we reach a total of 1.6 billion page views. This means that every single minute, we're going to deliver 37,000 articles to our users. So it's quite a considerable customer base we have out there. Now, I've mentioned that we operate in 12 markets. However, if you look at the map, we can see that these areas are quite geographically dispersed. Historically, all the markets had quite an individualized and tailored tech stack with very little shared components in between them. So 2 years ago, we kicked off a digital transformation project that aimed to create this one global platform. And more importantly, we wanted to distribute it globally. So currently, we have our platform replicated in 5 different regions, making a total of 9 clusters. We have 3 clusters in Europe, a dev, staging, and production one, to deliver the content for our European markets. The cluster in Tokyo is going to deliver the content for our Taiwanese, Japanese, and Indian customers, while the cluster in North Virginia is going to focus on our Mexican market. In China alone, we have 2 dedicated clusters, a staging and a production one, while we have 2 more clusters in Dublin to host our internal tools. Now, if you look at the map, you can see that we don't have a replica of our tech stack in Russia. This is because the current strategy is to deliver the content from our European servers while having a CDN, which is Russian-oriented. This will allow us service availability in Russia while investing minimal engineering effort. I would like to focus a bit more on Russia and China. Now, from these 2 countries alone, we have 60 million unique users every single month, and they represent 20% of our entire digital readership. It is quite a considerable customer base, and Condé Nast should be prepared technically to meet the demand in these areas. Now, deploying infrastructure to countries like Russia and China can be quite challenging from an infrastructure standpoint. When we kicked off the project for a global platform, we did not have a clear vision of one cloud provider that's going to be used for all platforms in all regions. As such, it was our decision to use a self-hosted solution for Kubernetes, meaning that we're not going to outsource it for anyone else. We're going to take it and manage it ourselves. Now, there is another reason I mentioned Russia and China. Yes, it is challenging to deploy infrastructure into it, but what we wanted is to use the same set of tooling for our developers to interact with these regions. We wanted to make it less disruptive, or actually make it very, very consistent in terms of the set of toolings. And I would like to give a bit more of our Kubernetes setup. Now, Kubernetes underpins the entire infrastructure of Condé Nast. We are a CoreOS house, meaning that we're using Tectonic installer for our cluster deployment, and we're using etcd for the storage of our cluster data. Now, using Tectonic allows us to plug it into different cloud providers while using compute and networking resources. This allows us to be be vendor agnostic while deploying 100 open source Kubernetes in a multi-master, multi-node fashion. Again, this kind of allows our capability to lift and shift our infrastructure even to countries like Russia and China if need be. Our platform is live since October last year when we first launched GK France. Since then, we migrated 2/3 of our intended estate, which is 35 websites. And so far, we serve more than 260 million page views every single month from our backend systems. So we accumulated quite a considerable amount of requests we serve. Now, I've given you an overview of how we actually distribute our infrastructure, of how we manage infrastructure. I would like to focus on our developer experience. Now, at Condé Nast, the cloud platform team believes that having a solid, well-defined CI/CD process is the way to move forward in terms of enhancing the developer experience. Currently, we have around 40 developers, and this is the London office, which are spread across 8 teams. Historically, in accordance to the business objectives, we deployed around 40 microservices, and currently we reach around 15 deployments every single week to production, which kind of shows our high ratio of feature build-out. Supposedly, we have a developer that would like to deploy a new application to our cluster, or even if they would like to change any settings to the application. The way to go for that, they'll require 2 dependencies. First, they will require a Dockerized version of the application, which is going to be stored in key.io, which is our Docker image registry by choice. Secondly, they require a configuration file for our Helm charts templates. Now, once the dependencies are available, the teams will be able to interact with the circle-side pipeline, which is going to deploy their application to Kubernetes. When the application is live, they will be able to log in into the cluster and interact with it. Now, what's worth to mention here is that we have 5 different, well, actually they're going to deploy to 4 different clusters with different regions. And they will have the ability to tailor every single application to every single region. This is actually quite important to actually make sure that you have the right size of your clusters and to actually have the content or the infrastructure right size to the region. I would like to put a bit more focus on Helm. Now, Helm is our de facto deployment packager to Kubernetes. Historically, we developed around 10 Helm charts, which are maintained and built in-house, and these are allowing our developers to deploy their application. To actually do that, we have a base Helm chart. Now, the base Helm chart will deploy a fundamental deployment and a service account associated with it. At this stage, the application is not going to be available to the traffic or internal or external users. To do so, they'll have to enable ingress and service resources. To do so, with Helm, we have dependent subcharts where they can be enabled based on the flags. So we have ingress, service, and HPA. And this is pretty much the entire suite of configuration the developers will have available for the application. As well, we have in-house built Helm charts for network policies, resource requests, cron jobs, and jobs. And we actually use a different flavor of FlowInD. We're actually thinking to move upstream in the future as well. In terms of the settings, this is pretty much what the developers have to configure the application. Now, this is quite a nice abstract layer they have. They don't need to care about the infrastructure. They just need to provide values for these settings, such as the image, which is going to be usually from key.io, amount of replicas, any annotations, liveness and readiness probes, HPA objects, and so forth. So a typical configuration file is going to be looking something like that. I hope this is visible from the back. So we have a name for our application, which is going to be Asimov, and the image is going to be stored in key.io, and we want free replicas for this application. As well, we enable a service, and we want to expose our application on port 80. And in terms of ingress, we say that we want to use a traffic-restricted load balancer for asimov.ui.cni host. Now, it's worth to mention at this moment that we have 2 load balancers available for every single namespace or for every single application. One of the load balancers is going to be public, and one is going to be restricted. With the public one, they'll have anyone is going to have access to the application, while with the restricted load balancer, we're going to filter based on the source IP of the user. Now, we've talked about how developers interact and deploy to our platform. I would like to focus on the support topology. Now, this is going to be from the cloud platform perspective, and more importantly, how we cooperated and change our identity throughout to actually empower our developers and their application. Historically, when I say that, it's around 2 years ago, we had one cloud platform team, which was responsible to deliver the main components for infrastructure. At the time, we had a bi-weekly rota to actually support our engineering queries. This was great. However, throughout time, the more mature was our infrastructure, the more complex query we had from our developers, and the amount of queries was actually quite overwhelming. So it was, we had a transition which divided our team into functions. We had the cloud platform and we had the cloud management team. The cloud platform was still focused on delivering the main infrastructure bits. However, the cloud management will focus on upskilling the developers and advocating for the best ownership practices for the application. And recently, and this is happening for, I think 5 months now, we have a new function, which is the SRE. And this is the target support topology model we actually aimed for. With the SRE, we have the site reliability being an area of ownership in its own, and we have actual developers thinking about this and actually pushing for the best practices. So this is our transition that happened throughout 2 years. So we actually changed our identity and transmorgify to support our developers in the best case. If we're thinking about this transition in DevOps topologies, this is pretty much our transition. We used to be a type 3 of DevOps topology, which is infrastructure as service. We pretty much would deliver our infrastructure on demand. In the second phase, we actually were still infrastructure as a service, but we transitioned more into a type 6, which is advocating for DevOps culture. And now we actually transitioned to type 7, which is the Google SRE model. Now with the SRE, I'm actually quite excited about this function because they actually have the power to push back on feature development and based on SLOs to bring back tickets from the backlog, which will have customer impact straight away. As well with the SRE, we're going to have a more defined and structured model for disaster recovery and incident call, and more importantly, on-call rotas. So let's talk about the results of all this collaboration and extended and proximal collaboration between the infrastructure and developer teams. Actually, before I do that, I would like to focus a bit more on what open source is, to be honest. Open source is a method for a software development which is decentralized, but at the same time, it encourages collaboration and contribution from the users. We had a very similar use case with Helm, where we have our Helm charts and built in-house, but we have our developers contributing to them. They didn't go the original way to actually create a ticket, wait for us to prioritize it, pull it back, pull into the sprint, and then work on it. They actually did it themselves with us helping them as well. And I would like to present to you some of the use cases of what these contributions were to our Helm charts. So the first one was to actually add graceful termination to our pods by using the pre-stop handlers. Now, to give you a bit of the context why this was required, at the time we had a lot of 500s, 502s, and 504s to be more specifically from our application. So when we actually terminated a pod, all the requests there would be a latency to actually wait for the new endpoints. Now, all the new requests will still go to the kind of terminated pods, which created 500s, and the ongoing requests as well, they were 500. With the pre-stop handler, we would have a command which will wait for 10 seconds before the pod will be terminated completely. Now, this will actually subdue the 500 errors, making a cleaner and nicer graph for us to look at. A different contribution was to add target average value for our Helm charts. Now, our developers are able to scale their application horizontally by using CPU memory, but as well they actually can do that with external metrics. And what they actually wanted is to use the target average value for the HPA, which allowed them to keep the ratio between the amount of pods and the amount of workloads. So this is quite a nice addition, and quite a fine one as well. A different one was to add pod annotations to our cron job pods. Now, This was required to actually propagate the AWS permissions to the pod. The developers wanted to create a more controlled environment for the container to interact with AWS API. So again, this is quite an important thing to have in mind. And the last one was from our developers. They actually wanted to store credentials or more sensitive data, to mount actually more sensitive data to their containers. This was possible by using the secret volumes. And again, this was added to our Helm charts. So in total, it was quite a nice addition of features that was very kind of tailored for the application and required by the application teams. We actually have a very similar inner source practice with Terraform modules. Throughout, we have developers, actually, they took ownership of particular modules and they would actually contribute to them. It ended up that the cloud platform team would use modules created by our application teams, which is quite an interesting place to be in. But it worked, and it's amazing. So overall, we talked about our developer experience and how we try to enhance the way our developers interact with our platform and deploy to the platform. Secondly, we actually focused on support topology, and this is how the cloud platform team actually metamorphosized throughout 2 years to best deliver support to our application teams. And lastly, we talked about our results, which is to create micro open source communities of Helm, but we encountered that with our Terraform modules as well. So I think, in conclusion, overall, it is quite a challenging task to make our developers happy. However, we managed to create this kind of cohesive environment, which doesn't only enable our developers and their product, but it actually creates initiatives for micro open source communities or inner sourcing. I have recently summarized all of this into a blog post, so if you'd like to know more or reference it, please have a read. And if you have any questions, please follow me on social media. I'm more than happy to answer any queries, or you can talk to me after the talk. And if you would like to work with us, please visit the link provided here. Thank you.
Thank you for your talk.
Thank you.
I just had a question around the size of the teams. I think the cloud management team, the SR team, and the cloud platform team, that's a really nicely split set of people. How big are these teams, roughly?
So we actually, well, now we have 4 developers in cloud platform team. We have 3 developers for our cloud management, so they are going to be interacting with our developers. And we have 3 for our SRE. So in total, 10 developers. And this excludes the team leads and the managers. Yeah.
Thank you so much.
Thank you.
Hi. How did you drive community involvement within the organization to try to engage your developers to contribute, like learn Helm and the ins and outs of templating and convince them like it's all going to be worth it to learn Go templating in the end?
Absolutely. I think for us it was always a motivation to make it as easier as possible for our developers to deliver their application to the cluster. Now we try to abstract as much as possible. So what they have to do usually is just that configuration file, so like a couple of lines, and that's it. And they're quite happy with it. Now, the reason for us to have the biweekly rota to interact with our developers and have time specifically for them, and then transitioning to the cloud management team as well, which it was all about upskilling developers. Now, to be honest, they were actually quite proactive, and it helped us a lot. And at the same time, they were proactive. We were very ready to help them, and it was quite kind of a nice collaboration in between. So it was definitely based on, proactiveness from both sides. But I would say I know it's difficult in some other environments. For us, I think we have great developers with a very open mind, and they were just happy to contribute and learn more. So I would say we're quite lucky.
Yeah, thank you.
So you talked about the transition from, was it type 3 to 6 to 7. So just curious, what were some of the things, what were some of the motivations that caused you to go from one to the other? What were some of the other things you tried that may not have worked? And were those changes kind of bottom up? You know, were the developers asking for them? And could you just talk about your journey on that?
Right. So, that's a very good question, actually. There is a lot of background and context of how we actually cooperated with our dev teams. But I think so at the beginning, we just like one cloud platform team, and we would deliver everything, and we had like all the queries, and we're working in a campaign style as well, which I think throughout it kind of made it more difficult for us to have a higher velocity on providing our infrastructure features. So at the time, we're like, okay, so we still need to deliver the global platform. We still have to have the migration of the markets to our platform. We need to focus a bit more on our infrastructure, but at the same time, our developers are quite important. Like, we cannot just like leave their queries in the air, like their demands. So I think this kind of transition was in a way natural, but in a way our team lead and management team, they're actually working quite hard to understand the needs of the developers. So I wouldn't say it was necessarily top down, because it's just like two layers which, you know, collaborate all the time, and they always kind of know their situation. And it's a small team, and kind of makes it easier for us to gather feedback. So I'd say the management team, they were actually doing a great job of identifying that we actually need this cloud management team, and then transition to the need for us to have the SRE team, because our set of monitoring, for example, was absolutely horrendous. But now it's not, because we have this SRE team which is actually focusing on delivering these monitoring alerts based on KPIs, and they will have this holistic vision of microservices in between. So I think this is kind of, the more mature we are, the more kind of requirements we see, like areas we need to be involved in or to contribute to. We identify them, and based on that, we actually change the shape of our team. So it's kind of a continuous process, I would say. Yeah. Thank you very much.